16 quarterly observations. The following regression was estimated from 16 quarterly observations. T ratios are in parentheses. T ratios are in parentheses.
Question to repeat.
The following regression was estimated from 16 quarterly observations. 16 quarterly observations. T ratios are in parentheses. T ratios are in parentheses. So please write down the model. YT is equal to 70.7 minus 0.90 xt plus 0.43 S1T. S for seasonal dummy. Instead of using the notation capital D, we are using capital S. Plus 6.55 S2T minus 2.83 S3T. So this is the estimated model and T ratios are there in the parenthesis. So please write down the value of the T statistics. 3.7. Yes.
Ma'am, could you repeat the regression?
Okay, I didn't. Just a minute. I thought I'm presenting the things. Is it visible?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. So please write down the equation. YT is equal to 70.7 minus 0.90 xt plus 0.43 S1T plus 6.55 S2T minus 2.83 S3T. Write down the T statistics: 3.7, 0.27, 3.37, 3.40, again 3.37. Capital R square is equal to 0.68. SIT is equal to 1 in the ith quarter. Zero otherwise. SIT is equal to 1 for the ith quarter, 0 otherwise. The question is, explain the implied pattern of explain the implied pattern of seasonal variation. Implied pattern of seasonal variation and interpret the result. Explain the implied pattern of seasonal variation and interpret the result. Okay, so have you written the question? It's complete? Yes or no?
Ma'am, the question was explain the implied pattern of seasonal variation.
Yes. And interpret the result. Okay.
Yes, ma'am, got it.
Okay. So, how I'll proceed. I have a whole model. I have the estimated model where we have the explanatory variable xt, and I have three seasonal coefficients, S1t, S2t, S3t. And it is said that the following regression was estimated from 16 quarterly observations. So actually we are dividing the whole year into 4 quarters. Okay. Since there is intercept in the model, we are considering 3 seasonal dummies. The original intercept will indicate the dummy for the last season or the 4th season. Okay, so looking at the regression to begin with, we are understanding that we have 4 seasons, and for that matter, we are incorporating 3 seasonal dummies of binary format because the model has the interceptor. If I incorporate 4 seasonal dummies, there will be the problem of dummy variable trap. So please write down. There are, or please write down, since the data is a quarterly data, this implies we have 4 seasons. Since the model originally has an intercept term, we incorporate 3 seasonal dummy variables, 3 seasonal binary dummy variables to capture the seasonal variation, in our model.
Ma'am, could you repeat the last part?
Since the model has intercept term, we are incorporating 3 seasonal dummy variables of the binary form to capture the seasonal variation in the model.
Thank you, ma'am.
Now, if you look at the T statistics are there in the parenthesis. For 3 seasonal dummy variables, T statistics are 3.37, 3.40, 3.37. So can you tell me whether the seasonal coefficients are significant or not? Are the seasonal coefficients significant? If yes, why yes? If not, why not? Abhishek?
Yes, ma'am.
So are the coefficients significant? Looking at the t values, can we tell that the coefficients are significant or not?
Yes, ma'am. Significant.
Why you are telling significant?
And because the p-value is high.
High in the sense? Greater than 3.
Greater.
If the t values are greater than equal to 3, in that case, we do not need to compare it with the tabular value. These are always significant. If the t values are modulus t values, of course, if the modulus t values are less than 1, in that case also we do not need to compare it with the tabular value. The coefficients are always insignificant. So take a note, earlier also I mentioned t statistic, if it is greater than equal to 3, the coefficient is always significant, t statistic. If it is less than 1, then it is always insignificant. In between, we need to compare the values with the statistical table. So looking at the, Abhishek has rightly pointed out, the t values are very high. However, you need to clarify the matter. Since it is greater than equal to 3, therefore t statistics, all three t statistics are significant. That indicates, all the three seasonal dummy variables significantly explain the variation in YT. So please write down the t statistics associated with three seasonal dummy variables, or you can write the coefficients of three seasonal dummy variables. The t statistics associated with the regression coefficients of three seasonal dummy variables indicate that all three coefficients are statistically significant, and hence the seasonal dummy variables explain the variation in YT. Okay, so this is the starting point. This is the starting point. Now, for the 4 quarters, how I can get separate regression equations? For the 4 quarters, how we can generate 4 regression equations and can compare the results? How we will be able to generate 4 equations out of this single regression model? Anyone? Pratyush?
Ma'am, for the first quarter, if SIT denotes the first quarter, then in first quarter only SIT value will be 1 and the other values will be 0. S2T and S3T, those will be 0.
Very good. So following that principle,
And
please generate the equations for first quarter. Pratyush is absolutely right. So generate the equations for the 4 quarters, first, second, third, fourth. Following that principle, please generate 4 equations, 4 relevant equations for all 4 quarters.
Ma'am,
Yes.
ma'am, we use the additive dummy principle here, right?
Is there any other alternative?
No, ma'am, we are not considering slope differences here, so
So what will be the equation for the first quarter? Pratyush, please state the equation.
Ma'am, it is 70.7 minus 0.90 xt plus 0.43.
Plus 0.43.
43.
So we will add 0.43 with 70.7. So it is 71.13. This is the model for the first quarter. For the second quarter, what will be the model? Anyone else?
Ma'am, we'll have to consider x2t equal, sorry,
Miss YT equal
Yes, yes, please continue.
ma'am, so S2T will be 1 and S1T will be and S3T will be 0 each.
Okay.
So,
Will it
ma'am,
be this equation?
yeah, so 77.25 minus 0.90 xt.
What will be the intercept for the third quarter?
$67.87.
Very good. And finally, for the fourth quarter, what will be the equation, Shibani?
70.7 minus 0.9 xt.
Very good. This will be the equation for the fourth quarter. Okay. So please write down. Here, slope coefficients has remained unchanged. And the seasonal variation has been captured. Seasonal variation has been captured by the changes in intercept term. By the changes in intercept term. Which one has the highest intercept?
Second quarter.
Second. It is followed by
First quarter.
71. It is followed by 4.
Fourth.
Very close. And this is followed by third. So red one is the second. Second quarter. Green one is the first quarter. Blue one is the fourth quarter. And this is Q3. Now, when we will compare the lines with respect to which line we will compare the rest?
Fourth line, fourth quarter, the line corresponding to fourth quarter.
Corresponding to the fourth quarter. Why that's so? Why we will compare with respect to fourth quarter? You are absolutely
Ma'am, because that is, ma'am, because we are considering that to be in the intercept term, that is the reference quarter.
this is that.
That effect is captured in the intercept term.
So please write down, very good. Please write down the fourth quarter is the reference category here. The fourth quarter is the reference category here. And hence, the seasonal variations will be compared with respect to fourth category. With respect to fourth category. Both the first and the second quarter, both the first and the second quarters have greater seasonal variation compared to the fourth one. Although or don't write although, for both the quarters Q2 and Q1, that is first and second quarters, have higher intercept compared to the fourth quarter. However, fourth quarter shows bigger seasonal variation, bigger seasonal variations with respect to Q4 compared to the variation of Q1 compared to the variation of Q1 with respect to Q4.
Ma'am, could you repeat this part?
Please check it later. Third quarter presents lesser seasonal variation. Third quarter shows lesser seasonal variation compared to the reference season, compared to the reference season that is Q4. That is Q4. So last day when you learned the theory, you learned, how to incorporate more and more dummy variables, intercept dummy variables, and if there are several layers, how to incorporate those layers, etc. And today you are getting one numerical example, where you are getting the ideas, how to interpret the model or how to generate different models out of a single model. So I hope if there is interactive dummy as well, along with the intercept dummies, here we have used only the intercept dummy because slope across the 4 lines have remained constant. However, if I bring one multiplicative dummy or the dummy capturing the interaction, then also I hope you will be able to interpret in the same way. In that case, along with the changes in intercept, you need to check the changes in slope. So when the curve will be flatter, when the curve will be steeper, this thing also you need to add. Here the lines are the parallel lines because the slopes are identical across the lines. However, if we incorporate an interactive dummy, say SIT, XT kind of dummy, that is interactive dummy, in that case, I hope you will be able to interpret in the same way. So look at the theory, look at the kind of interpretation we are doing, and incorporate one interactive dummy as well. And if the one interactive dummy is incorporated, how we will consider the changes, etc., that I hope you will be able to discuss. So if anyone have any doubt, any query regarding the interpretation of the dummy variable, how to do these things, please let me know. Otherwise, I'll give example, or we will discuss example from other chapters. Any question regarding the dummy variable, interpretation of the dummy variable? If I incorporate a slope dummy along with the intercept dummy. So everything is fine with all of you? Okay. So I'm moving to another chapter, or I'm moving to another problem. So now I'll discuss problem on prediction. I didn't discuss problem on prediction part. So I'll discuss a problem on prediction part. Now in context of prediction, I talked about the point estimation as well as I talked about interval estimation or point predictor, interval predictor. And this discussion we did for y naught as well as expected value of y naught. So there are four things. We derived the value of y naught on the basis of x naught, and then we learned how to set the interval. You can find out a specific value of the predictor, or you can find out the interval within which the predictor will lie with a very high probability. Okay. Now, there is uncertainty inherent in the basic structure of econometric model building exercises. And for that matter, we learned to derive expected value of y naught as well, and how to set interval for the expected value of y naught. So all these things we did theoretically. However, we could not discuss the numerical exercises because that part was not included in the internal assessment part. So now I am going for that. I'll discuss a few problems from Madala. Okay, so you have the book, the soft copy of the book with all of you. So chapter 3. Chapter 3, the problems 13, 14, 15, 16, these problems are based on prediction. Okay. So if you cannot open the numerical exercise, no problem, because I'll tell you the problem. So I'm starting with problem number 16, part A. Part B is not there in our syllabus because I didn't discuss about the inverse prediction. Inverse regression or reverse regression I discussed. However, I didn't talk anything about reverse prediction because under most of the circumstances, we will go for general prediction. Under few circumstances, we consider the reverse prediction as well. That is, given the value of y, how to predict the value of x. Okay, it's not that this we don't do. However, more common is on the basis of the value of x, we predict the value of y. Okay, so problem number 16 in chapter 3, Madana. In the model, yi is equal to alpha plus beta xi plus uy. I running from 1 to n. The following sample moments have been calculated from 10 observations. Following sample moments have been calculated on the basis of 10 observations. So n is equal to 10. Summation capital yi, that is equal to 8. Summation capital xi, that is equal to 40. Summation yi square, that is equal to 26. Summation xi square, that is equal to 200. And summation xi yi, that is equal to 20. The question is, calculate the predictor of y I'm calling it y naught. Predictor of y I'm calling y naught for x is equal to 10. 10 is x naught. The specific value of x is equal to 10, and derive 95% confidence interval for this. Okay, so this is the problem. Calculate the predicted value of y naught for x is equal to 10 and derive 95% confidence interval. So how we will proceed? What we have to derive first?
Ma'am, alpha hat, beta hat.
Alpha hat, beta hat, yes. We have to find out the values of alpha hat, beta hat. So you have the information. Using the information, find out alpha hat, beta hat first. All the information are with you. Summation yi, summation xi, these are there. So you will be able to calculate y bar, x bar. And then you will be able to calculate alpha hat, beta hat.
Ma'am, number of observations কত ছিল?
10. So if anybody has any confusion, look at equation number 1. How we calculate the predicted value of y dot, or what will be the structure of the predicted value of y naught. Y naught hat is equal to alpha hat plus beta hat x naught. y naught hat is equal to alpha hat plus beta hat x naught. So for that matter, you are actually calculating alpha hat and beta hat. X naught value is given. So once you calculate alpha hat, beta hat, please calculate alpha hat plus beta hat x naught. That will give you the value of y naught hat. The
Ma'am,
value
is
of
beta hat minus 0.3?
which one?
Ma'am,
मैम
beta hat
अल्फा
only.
हैट আসছে 2 আর বিটা হ্যাট -0.3
Yes, ma'am.
Alpha hat আসছে 2 আর beta hat কত
হ্যাঁ
আসছে? Minus
-0.3 -0.3
yes, minus 0.3. Yes. These are the two values. What is x naught?
10
Okay, so what will be this value?
मैम -1
Minus 1. So first part is complete. Now you have to set the interval. So actually we proceeded and got the value of the interval in this format. So if you look at the theory part, there are a few steps. Actually, we derive the variance of E naught, okay, expectation of E naught, variance of E naught, and, finally, we got this interval. So this you need to find out. Alpha hat plus beta hat x naught plus minus t 0.025. If nothing is mentioned, we will consider the test at 5% level of significance, So 95% confidence interval will be given by this formula. So please write down the formula first. The 95% confidence interval for y naught hat. Or better to say y naught, because it is the interval estimation for y naught. The 95% confidence interval for y naught is given by alpha hat plus beta hat x naught plus minus t 0.025. And what will be the degrees of freedom here? T, actually t n minus k comma 0.025. So what will be n minus k here?
8.
8.
meet it
8, yes. So it will be T8 0.025. S into root over 1 plus 1 by n plus x naught minus x bar whole square divided by summation capital Xi minus x bar whole square. So please write down the formula first in a right way, and then you need to calculate several components. You need to calculate S.
ম্যাম সরাসরি ফর্মুলা বার করতে পারি তো, মানে ডিরাইভ করতে হবে না তো?
যদি ডিরাইভ করার উপর পার্ট থাকে করবে। এসটা কিভাবে ডিরাইভ করছো?
Square root of RSS by n minus 2.
Square root of RSS by n minus 2. Yes. So please find out TSS, ESS. TSS is summation yi square minus n y bar square. In the same way, you will be able to find out ESS. Beta hat into summation xi minus x bar into yi minus y bar.
ম্যাম বিটা হ্যাট স্কোয়ার সামেশন xi মাইনাস nx বার করতে পারি তো?
হ্যাঁ হ্যাঁ, দুটো ফর্মুলাই করতে পারো, একটু ডেসিমাল প্লেসে ডিফারেন্স হয়ে যায়, এছাড়া আর কিছু হবে। একটা স্মল ভেরিয়েশন ইন যখন আমরা নিউম্যারিক্যাল করি, দুটো অল্টারনেটিভ ফর্মুলায় 100% সিমিলার আসে না বিকজ অফ দ্য ফ্র্যাকশন পাথ। However, that difference is acceptable. If anybody has any problem regarding the formula, regarding understanding, please let me know. I'll write down the formula. জাস্ট চুপচাপ বসে থেকো না, কোথাও অসুবিধা হলে প্লিজ কাম আউট, ফর্মুলা গুলো লিখে ফেলা যাবে। Most of the exams will be one-to-one kind, so please prepare yourself accordingly. আচ্ছা বলতে থাকবে কি করছো? এসটা কত বেরোলো? 1.34?
ম্যাম এক মিনিট। ম্যাম 1.31 আসছে।
1.31?
হ্যাঁ
ওই 1.3 ওটাই বললাম, যারা হয়তো ওইটা ফর্মুলাটা করেছে তাদের 1.34 আসবে। সো রাফলি 1.3। বাকি আর কেউ করেছো? এসটা ডিরাইভ করেছো? দর্পক এসটা কত বেরিয়েছে?
আমার √2 এসেছে।
ইয়েস ম্যাম, আমারও ওটা অ্যাপ্রক্সিমেটলি 1.414।
1.34?
1.414। আমি বিটা হ্যাট স্কোয়ার্ড সামেশন স্মল এক্স আই স্কোয়ার্ড ইউজ করেছি।
ম্যাম হ্যাঁ 1.41, সরি 1.41 আসছে।
আচ্ছা দেখো 1.3 1.4 কি বেরোচ্ছে। এটা বেরিয়ে গেলে তোমরা ওই ফর্মুলাতে পুট করো alpha hat plus beta hat x naught. That means 2 minus 0.310 this part plus minus t8 0.025 SU into root over 1 plus 1 by n plus x naught minus x bar whole square divided by summation xi minus x bar whole square. So this will be the thing. So 1 plus 1 by n ten minus 4 by 40, 10 minus 4 whole square by 40 এরকম আসছে কিনা। x naught minus x naught is 10 minus 4 is x bar whole square by summation xi minus x bar whole square or summation xi square minus n x bar square.
হ্যাঁ ম্যাম 1 প্লাস 10 মাইনাস 4/40, মানে 10 মাইনাস 4/40 হোল স্কোয়ার।
এবার এটাকে সলভ করতে হবে তোমাকে। t8 0.025 এই ভ্যালুটা বসাতে হবে।
ম্যাম
হ্যাঁ ইয়েস।
ম্যাম একবার ওই কুড ইউ গো ব্যাক টু ওই ইন্টারভাল এস্টিমেটের ইকুয়েশনটা?
হ্যাঁ ইয়েস।
ওকে ম্যাম।
টেবিল চেক করে কেউ একটা বলো T8 0.025 কত? What is the value of T8? 0.025. Tiyasha, would you please tell us?
Ma'am, 2.306.
2.306. Okay. 2.3 নিয়ে নাও। নিয়ে নাও। এই তিয়াশা হচ্ছে?
ম্যাম যদি এই ভ্যালুটা নিয়ে কাজ করি তাহলে ইন্টারভালটা আসছে -5.6, 3.6।
এই ভ্যালুটা নিয়ে কাজ করি না,
মানে এই টি এর ভ্যালুটা নিয়ে কাজ করলে
এটাই নিয়ে তো করবো। 5.6 আর
3.6 আপার।
ম্যাম আমার 2.6 আর 4.6 আসছে।
না এত কম তো আসবে না। আমার সামেশন xi yi ফর্মুলা ইউজ করেছিলাম, আমার আছে -5.36 মানে -5.4 রাফলি, আর 3.36 3.4। সো এই টাইপের ভ্যালু আসবে। দেখো তো একটু কোথাও মিস্টেক আছে। বাকিদের কার কি আসছে বলো।
I'm 3.46 and -5.46.
হ্যাঁ ওই টাইপের, ওই রকম -5.46 আসতে পারে, আর 3.46 বলছো তুমি?
Yes, ma'am.
মানে সামথিং লাইক দিস। এটা -5.6 3.6 হতে পারে, -5.5 3.5 হতে পারে, যেটা শ্রেয়া বলছে। সো ইট উইল বি, দ্য রেঞ্জ উইল বি লাইক দিস। And what was your point predictor? What was the value for the point predictor? যেটা আগে ডিরাইভ করলে?
-1 তো
-1. So definitely that is lying in between this range. Achha, is there anyone who didn't understand how we are proceeding? If there is some mistake in the numerical figure, then it is doable. You will be able to do it. However, if there is anyone who is not understanding what we are doing, how we are getting the values, please let me know. Because we will not have much classes, today I am discussing examples. If I cannot complete everything, then there will be one more class, that's all. So And then, if anyone has any problem in that case, if you send a mail or call me, in that case, we can clarify. Okay, so if there is any problem in understanding, and I am repetitively telling that most of your exams will be one-to-one. There will be some time-bound exams, however, most of the exams will be one-to-one. Okay, so in that case, you have to do this. Sometimes you have to solve some numerical exercises, sometimes proof, sometimes, you have to analyze the concept, so all these things are there, so please try to learn the things.
ম্যাম বলছিলাম যে স্টেপটা ঠিক থাকলে হলো, মানে অ্যান্সারটা যদি যে স্টেপগুলো থেকে আসছে ওই স্টেপগুলো ঠিক থাকলেই হলো, তো ইন্টারভালের অ্যান্সারটা বের করে।
এত বড় হয়ে গিয়েছো, এইসব কোয়েশ্চেন্স গুলো আর জিজ্ঞেস করুন, কেমন? অনেকবার অনেক পরীক্ষা দিয়ে গুলো দেখতে পাচ্ছ, সো ভাইভাও দিয়ে ফেলেছো অনেকবার, সো ডোন্ট গো ফর দিস কোয়েশ্চেন্স। Okay, so is there anyone for whom I need to repeat anything? Otherwise, please add one part, I'm not doing the part B, which is given there in Madala. Rather, we are adding one other part here. So this was the theory, what we mentioned, that sometimes instead of talking about the point predictor or interval for that predictor, we go for expected values of the predictor. We do not find y naught, rather we find the mean predictor, that is expectation of y naught, because of inherent randomness in the entire structure. Okay, so part B, instead of considering the actual predictor, if we consider the expected value of it, what will be the value of the predictor? And what will be the relevant interval? What will be the value of the predictor and what will be the relevant interval? Suppose this is the question. So if you look at the slide, the estimated value of this expectation of y naught, that is also given by alpha hat plus beta hat x naught. So expectation of y naught, if I consider expectation of y naught, that will be alpha plus beta x naught. Expectation of u naught is equal to 0, so that part vanishes. So we are left with alpha plus beta x naught, and if I estimate this value, it will be alpha hat plus beta hat x naught. So it will be similar to the value of the point predictor which we got earlier. Y naught hat is equal to alpha hat plus beta hat x naught. So both y naught hat and a hat of expectation of y naught, these are giving us the similar value. These are giving us the similar values. Okay, alpha naught plus alpha hat plus beta hat x naught. Okay, so whatever value you got earlier, you will get the same value if we go for the estimation of expected value of y naught. However, there will be a little bit change in the confidence interval. Actually, if we consider the variance of these particular predictor, if we consider the variance of this, if you look at the states, you will find that 1 plus part is not there. There was 1 plus part in the earlier case. That 1 plus part is not there. Okay? Because in the earlier case, it was y naught minus expectation of y naught, and in y naught there was u naught. So from there we got one more component. However, this component is not coming here. Okay, so your interval will be changed a little bit. So already the calculation of S is with you. So you have to recalculate this entire thing, considering all the earlier values apart from the fact that 1 plus. That part will be not there. So please write down hat of expectation of y naught, that is alpha hat plus beta hat x naught, that is equal to minus 1. I think you got the value minus 1. So whatever be the, you may consider y naught, you may consider expected value of y naught, the value will be similar. Both y naught hat and hat of expectation of y naught will be similar. So you got the value minus 1 as per I can remember?
Yes, ma'am.
Yes, ma'am.
Okay, so write down the value minus 1. And 95% confidence interval, 95% confidence interval for expectation of y naught is given by 95% confidence interval for expectation of y naught is given by alpha hat plus beta hat x naught plus minus t 0.025 by t 8 comma 0.025 s into root over 1 by n plus x naught minus x bar whole square divided by summation capital Xi square minus n x bar square. Alpha hat plus beta hat x naught is minus 1 plus minus 2.3 for S. You put your value root over 1 by 10 plus 10 minus 4 whole square divided by 40.
Minus 4.26, 2.26 আসবে।
এইটা এক্স্যাক্টলি বলতে পারবো না, দেখি বাকিরা কি বলছে, লিখে ফেলি। তুমি কি বলছো? রাজদীপ আগেরটা আবার ঠিক করে ভ্যালুগুলো বের করেছিলে?
হ্যাঁ ম্যাম, আগেরটাতে, হ্যাঁ ম্যাম আগেরটা ঠিক করেছি, বার করেছি।
বলে এইটা কি বলছিলে? মাইনাস
4.26 আর 2.26
2.23
26
Ma'am, এরমই আসছে, but minus 4.24 and 2.24.
Very good. So this will be the interval. So complete all the exercises based on prediction from Johnson, Donado and Madala's book. These are based on this kind of thing. Otherwise, in some problem you will be asked to find out the actual value of the predictor and setting interval. For this other circumstances, you will be asked to find out the estimated value of expected value of predictor and setting interval for that. Okay, so there will be a little bit variation in terms of variance, and for that matter, there will be a small change in the formula of interval. So So that 1 plus will be not here. However, you need to look at the steps, etc., because sometimes the question will come in terms of theory, sometimes the question will come in terms of numerical exercises. So you should learn how to do the steps, what are the implications of the steps, and then finally come to the numerical exercises. So complete all the exercises, from Madala it will be 13, 14, 15, 16 already done in the class. Okay, and from Johnston's book, I cannot remember the number, so there are 1 or 2 problems based on prediction. So complete those problems as well. So roughly there are 5-6 problems based on prediction. So complete all these things. And don't go for reverse prediction because we didn't do this thing in the class and that is not there in the syllabus. However, for advanced reading, if you like to go through the things, there is no problem in it. There will be no question from reverse prediction. Okay, so this is all about the prediction. Now I am moving to MLRM, multiple linear regression model. We discussed one numerical exercise, where we learned how using the matrix algebra, we can derive the values of the coefficients, we can derive the value of R square, ESS, TSS, etc. So standard things, how we derive, SU square. So all the standard thing, how we derive and how we can run the test, all these things we discussed. And I'll expect you solved at least 3-4 exercises based on 2 explanatory variables. Okay, 2 explanatory variables, if not more, because if we consider more explanatory variables, in that case the matrix will be bigger, so you may face some problem in solving these things. So the basic objective is whether you are learning the matter or not, so I know you will be able to solve very big matrices too. However, there is no actually here our focus is not in how we will solve the matrix. So we are applying those concepts. So if you consider 2 explanatory variables, then also it will be more than sufficient. Please practice some of the numerical exercise which is similar to, actually we did all the steps when we discussed the numerical exercise. So please solve for all these values for at least 3-4 problems so that it will be easier for all of you to understand the matter and solve the exercises. Today, I'll discuss some questions which are conceptual, which are true-false type, etc. So I'm moving to that. Yes, definitely. Okay, so please write down. Both in Johnston and Madala, you will have this kind of questions. True false type question, or conceptual questions. So first I am trying to discuss some questions based on multiple correlation, partial correlation, simple correlation, etc. So please write down, a student obtains the following results in several different regression problems. Okay, so please remember this line, a student obtains the following results in several different regression problems. Now you write down, in which cases could you be certain, that an error has been committed? Question mark. Explain. capital R square y dot 123 This is first question. Okay, suppose these three questions are there. Let's start with the first one. You have to tell me in which cases could you be certain that an error has been committed. So let's start with the first one. There are two multiple r square y dot 123, this is equal to 0.89, r square y dot 1234, this is 0.86. Okay, so what do you think? Do you think that any error has been committed or not? Before going to that, what does y dot 123 means? What y dot 1234 mean? So
Ma'am,
yes, who's there?
ma'am, this is Aratri.
Aratri, I like to have the answer from other guy, Let me call somebody else. Olipriya, would you like to explain? First, tell us, what does r square y dot 123 means and what r square y dot 1234 means? Olipriya.
Ma'am, I need a little bit of time to compose my answer.
You don't need to give answer, long answer. I just asking এই সিম্বল গুলোর মানেটা কি? r square y dot 1234 এই কথাটার মানে কি আর r square y dot 123 এইটার মানে কি? আগে এইটুকু বলো।
Ma'am, it's basically partial correlation.
Partial correlation. Okay, wrong answer. আচ্ছা, অন্বেষা দত্ত।
Yes, ma'am.
হ্যাঁ, বলো তো এটা কি মনে হচ্ছে?
Ma'am, multiple correlation
Very good, multiple correlation.
of y given x1, x2, x3 fixed.
Okay, so in the first model we have three explanatory variables, x1, x2, x3. Very good. And in the second model, how
Ma'am,
many?
there are four
Four
explanatory.
Okay, very good. Now first value is 0.89 and the second value is 0.86. So any idea whether there is any mistake? Can you tell me, Anisha, what is the formula for r square, multiple r square? What is the formula for R square? Aratri, could you please help Annesha? What is the formula for R square?
Ma'am, it
ESS
is
by TSS.
Yes, very good. ESS by TSS. So in that case, Annesha, if it is ESS by TSS, do you think there is any mistake? Orko?
হ্যাঁ ম্যাম এক মিনিট ম্যাম ভাবছি ওটাই করছি
ESS মানে কি? What is the full form of ESS? Annesha or Orko? Anyone?
explain sum of squares.
Explain sum of squares.
Ma'am, this might be wrong. The first question part A will be wrong.
কেন বলছো বলো তো?
Ma'am, because we know that R square is ESS by TSS and here TSS remains unchanged. So as we increase the number of explanatory variable by 1, the R square part must be increasing. It will be greater than 0.89, but here it is 0.86, which is less. So
Yes, great. This is the right answer. Okay, perfect answer. So, you have to mention the formula of R square. R square is equal to ESS by TSS. ESS is explained sum of squares. TSS is total sum of squares. So, the variation in yi remaining constant. Variation in yi is TSS. If I incorporate one more explanatory variable, always explanatory power of the model will increase or improve, and for that matter ESS will increase. So ESS by TSS will always increase. So here we are finding that the R square with lesser number of explanatory variable is 0.89, whereas with 4 explanatory variables it is 0.86. Definitely an error has been committed. Very good, Annesha. Okay, so this is the answer. Orko, ঠিক আছে? This will be the answer.
হ্যাঁ ম্যাম ঠিক আছে ম্যাম
প্রত্যেকে বুঝতে পেরেছো? So next we will move to the second part. R bar square y dot 1 2 3, R bar square y dot 1 2 3 4. So here what is happening, here also R bar square y dot 1 2 3 is 0.86, the other one is lesser. Okay, so Srijoni, can you tell us what you are thinking? What can be the answer? First, tell me what is meant by R bar square.
Yes, ma'am. R bar square is adjusted R square, and its formula is ESS by degrees of freedom and TSS by degrees of freedom. And degrees of freedom is n minus k, which is number of observations minus the number of parameters to be estimated. So over here we have, for the first case, 3 parameters to be estimated. So n minus k is lesser, and in the next case n minus k is n minus 4. So we have a greater n minus k, and therefore
তুমি যেটা বলছো n minus k greater lesser n minus k উপর ফোকাস করছো, এটা unnecessary. This is not related to this question. তোমার formula of the R bar square, yes, that there will be a revision to R square formula. We will deflate the ESS and TSS by the respective degrees of freedom. এইটা অবধি তুমি ঠিক বলেছো। তারপরে এই যে n minus এইগুলো কিন্তু irrelevant things, এগুলো আমাদের
আচ্ছা
নয়।
আচ্ছা ম্যাম, আচ্ছা।
এইবারে আমরা জিজ্ঞেস করছি যে R bar square with lesser number of explanatory variables সেইটা কি সব সময় বড় হবে কম্পেয়ার টু মোর নাম্বার অফ এক্সপ্লানেটরি ভেরিয়েবলস, ছোটও হতে পারে বড়ও হতে পারে, এই জায়গাগুলো ফোকাস করতে হবে। এই জায়গাটায় তোমার কি ধারণা? What is your idea about that?
Ma'am, as we increase the number of explanatory variables, ESS increases, but the degrees of freedom falls. So R bar square will be
তাহলে আমরা কিন্তু একেবারে ওরকম ভাবতে পারছি না। If there is an increase in explanatory variable, necessarily R bar square will increase, necessarily fall, এরকম কিন্তু কনটেক্সট নেই। It may increase, it may fall.
হ্যাঁ ম্যাম, বিকজ ডিগ্রিজ অফ ফ্রিডমটাও ফল করছে আর এক্সপ্লেনেটরি ভেরিয়েবল ইনক্রিজ করছে।
হ্যাঁ সৃজনী, মানে তুমি এটাই বলতে চাইছো তো যে মানে আমরা ঠিক কোন বুঝতে পারছি না, whether an error has been committed or not, we will be not able to come to this conclusion because there will be some adjustment with respect to degrees of freedom both in terms of ESS and TSS.
Yes ma'am, it's uncertain.
She has rightly pointed out the things ওরকমই জিনিসটা, however এটা আমরা আরেকটু স্পেসিফিক আনসার লিখে ফেলবো। So please take a note. By dropping an explanatory variable, R bar square will increase. By dropping an explanatory variable, R bar square will increase. If the absolute value of T statistic, associated with regression coefficient is less than 1, however, if the absolute value of T statistic of the corresponding coefficient is greater than 1, then dropping an explanatory variable R bar square falls. R bar square falls. So this is the criterion. So let me summarize this thing. If mod T or T square, these are greater than 1, Okay, so this is the criterion for R bar square. In both the cases, we are dropping an explanatory variables if the associated t statistic, modulus t statistic or t square is less than 1, dropping that variable R bar square will improve. If you drop the variable, R bar square will improve. However, if the mod t or t square is greater than 1, in that case, dropping the variable, R bar square will fall. So it will depend on mod t. Here we do not have any information on, so we will be not able to tell whether there is any mistake or not. Maybe there is a mistake, may not be. So if mod T4 greater than 1, in that case, it is a mistake. If mod T4 is less than 1, then we can have this result. Dropping the explanatory variable R bar square is increasing. It is becoming 0.86 in that case. Okay, so the answer is not unambiguous in this case. It will all depend on mod value of T4. So please look at these two statements, when R bar square increases, when R bar square falls, when we reduce one explanatory variable. If I need to give further clarification, please tell me.
If mod T4 is lesser than 1, the result is valid.
Yes.
Okay. In this case, T4, because number of explanatory variables is 4 in the second case. That's why.
There are 4 explanatory variables, x1, x2, x3. In the first model, there are 4 explanatory variables of x1, x2, x3, x4. T4 corresponds to the coefficient associated with x4. Suppose beta 4. Okay. T4 corresponds to okay. So suppose T1 T4 is basically okay. Any question, any query regarding this? So let's move to the final one, the third one.
ম্যাম এই লাস্ট পার্টটা বুঝতে পারলাম না, এই যেটা লিখেছেন এই T4 correspond to beta.
Aratrik asked, what T4 means. T4 is the test statistic corresponding to beta hat 4. That I am telling.
আচ্ছা ঠিক আছে।
তুমি কি বুঝতে পারছো না আবার? এটা বুঝতে পারছো তো, আগের মডেলটায় 3টে এক্সপ্লানেটরি ভেরিয়েবল আছে। মডেলটা হচ্ছে yi is equal to beta naught plus beta 1 x1i plus beta 2 x2i plus beta 3 x3i plus ui. পরের মডেলে 4টে এক্সপ্লানেটরি ভেরিয়েবলস আছে। yi is equal to beta naught plus beta 1 x1i plus beta 2 x2i plus beta 3 x3i plus beta 4 x4i plus ui. ওই যে beta 4 তার corresponding t statistic এটা।
আচ্ছা ঠিক আছে।
Okay. এবার লাস্টটা r square, small r square y dot 2 1.2 0.23, small r square 1.3 0.13, r square y dot 123, that is 0.82. So what we can say, is there any error or it is uncertain, we have incomplete information, anything can be the answer. Okay, so we have to explain what is happening here. So Darpak, what does small r square y1 dot 2 r square y1 dot 3, what are the meanings of these notations?
ওটা হচ্ছে পার্শিয়াল কোরিলেশন কোএফিসিয়েন্ট, মানে ওয়াই এর সাথে
r square y1 dot 3 মানে কি?
ওয়াই এর সাথে ফার্স্ট যে এক্সপ্লেনেটরি ভ্যারিয়েবলটা আছে তার পার্শিয়াল কোরিলেশন গিভেন ওই 3 নম্বর যে এক্সপ্লেনেটরি ভ্যারিয়েবল ওটা সম্বন্ধে জানি, আর ওয়াই এর সাথে ফার্স্ট এরটা নিচ্ছি।
Yes. So কিছু partial correlations আছে, আর ক্যাপিটাল R square y ডটটা কি?
মাল্টিপল কোরিলেশন কোএফিসিয়েন্ট।
মাল্টিপল কোরিলেশন কোএফিসিয়েন্ট। তো এখানে পার্শিয়াল কোরিলেশনস দুটো দেওয়া আছে ছোট ছোট ভ্যালুস, আর মাল্টিপল কোরিলেশনটা খুব হাই ভ্যালু 0.82। তো কিছু কি বলা যাবে এখান থেকে? সিটাতে কি আমি কিছু বলতে পারছি? মানে আমি যেটা দেখছি, given 2 y এর সরি 1 এর explanation power কম, given 3 1 এর explanation power কম, however there are several other partial correlations too, that is y1 dot 23, then y2 dot 13, y2 dot 23, y3 dot 12, এইসব আরো অনেকগুলো partial correlations আছে। So we do not have information on those partial correlations, and for that matter it will be difficult to come to any conclusion whether an error has been committed or not. So here there is the problem of incomplete information. Here there is the problem of incomplete information. Though we are finding that the two partial correlations mentioned here has very small values. However, overall, all three explanatory variables together can explain why, to some good extent, it is 0.82. However, we will be not able to say whether any error has been committed or not, because we do not have information on other possible partial correlations. So this will be the answer to part C.
হ্যাঁ হ্যাঁ।
Okay. Next, add a note. Add a note. In a regression model, if all the partial correlations, if all possible partial correlations are very small, all partial correlations are very small, however, capital R square, that means multiple R square, however, multiple R square is very high, that is considered as an evidence of multicollinearity. That is considered as an evidence of multicollinearity. So what I am telling, all partial correlations are very small. So suppose the regression model is UI. Okay. So I'm writing down all possible partial correlations. And multiple correlation. Suppose this is the construct. All possible partial correlations are very low and there is multiple, and the multiple correlation is very high. If this is the context, this is considered as an evidence of multicollinearity. Why? Because when you are considering all explanatory variables together can explain Y. However, when you are considering the fact that what is the capacity of x1 to explain the variation in yi given x2, x1 has nothing new to explain. Given x2, x1 has nothing new to explain. Why? Because x1 and x2 are linearly related. So given x2, x1 has nothing new to explain, or given x1, x2 has nothing new to explain. So for that matter, all the partial correlations are becoming very, very small. Okay. So if the problem C is revised a bit, and if I give all the values of the partial correlations, and if we find all the values are very small, in that case, it is the indication of the fact that given rest of the variables, a particular explanatory variable has nothing new to explain regarding the variation in yi. For that matter, these values are very small. However, when we are considering all explanatory variables together they can explain the variation in yi. Together they can explain the variation in yi. Okay. So given the rest, one new explanatory variable has nothing new to explain. However, together they can explain the variation in yi in a good way. So if this is the context, this is known as the problem of multicollinearity. Okay. This is happening because of the fact that all x variables are interrelated among themselves. Okay, so these kind of questions, conceptual questions, come from using multiple R square, adjusted R square, partial R square, etc. Any question?
Ma'am, so if the partial correlation coefficients are very small and the multiple R squared is quite large, we can conclude that we might have a multicollinear issue.
Yes. যদি তোমার কাছে all the partial correlation, all possible partial correlations দেওয়া থাকে, আর এই সি এর মতো ইনকমপ্লিট ইনফরমেশন থাকলে বলতে পারছি না, বিকজ অন্য পার্শিয়াল কোরিলেশনস গুলো হাই হতে পারে। ওকে, সো সি এর ক্ষেত্রে একটা ইনকমপ্লিট ইনফরমেশন প্রবলেম রয়েছে। There may be multicollinearity, may not be multicollinearity. If all the partial correlations are very low, this is definitely an evidence of multicollinearity. Otherwise, there may be some error in calculation, etc. Okay.
Okay, ma'am.
Okay, so check all these kind of questions, from, as I mentioned, numerical exercises or this kind of true false type questions you check from Madala and Johnston. So please check these